Hey, Period 5, how we doing? How are you guys today? Go ahead and send a message on the chat. Let me know who's here. Want to say hi to you guys. All right, cool. Then I guess I'll just get started with you guys. All right, so we'll start with the new unit. So let me just show you where to find all the information for Unit 6. So under Schoology, I already created a Unit 6 folder for you guys. So you can see here under complex numbers, that's where most of the information is going to be. So I broke it up into the homeworks, notes, and videos, little subfolders. So what I'm going to be doing right now is I'm going to be doing problems out of the foldable. If you want to print out the foldable and use it yourself, that's great. It's a little tricky to put together because I didn't, like, you don't have the double-sided copies like you usually get in class, but the problems are all there. So I'm just going to go ahead and do the things that are on here, but I'm going to do them like if we were doing them like on regular paper and, you know, like our regular notes. So it's all there. So if you do want to print it at some point and put it together, you'll have the notes so you can fill in the foldable for yourself a little bit later on. Okay. All right. So then the homework for this first lesson is already up. There it is, homework number 1. So after today, just go ahead and try to work on it. It has the solutions on the bottom of the page. So if you have any questions about how we got there, then on Thursday, what I'm gonna do instead is I'm gonna do like a homework session. So I'm gonna cut it down now to it's only gonna be 1 lesson a week, just to make sure that not too many people fall behind. I know some people watch the videos a little bit later, but I don't want to like do 2 lessons a week and then not have people be able to keep up. So on Tuesdays I'm going to do a lesson, and then Thursdays is just going to be like a homework session or a Q&A. So I'll probably set up like a Zoom conference on Thursdays instead, so that you guys can tune in and we can solve problems together, and you can ask me questions like more directly about the lesson. Okay, so then once we're done with the notes for today, I'll upload the notes, and then I'll upload a link to the video as well in case you need to go back and rewatch anything that didn't maybe make sense the first time. Okay, so that's kind of going to be the new routine, and so let's get started here on what the imaginary number I is all about. Okay, so the imaginary number I is something that we've looked at kind of informally, right? We've been doing a lot of quadratics, at least in the previous unit. We did some quadratics, and then when we did them by solving systems, we would sometimes arrive at something that was like imaginary solution, right? And then the imaginary was because we had a negative inside of the square root. So what I want to talk about here is that I want to talk about this kind of like diagram of what all of the real numbers, or all of the numbers that are included in kind of like the math world, are split up into these kind of like 2 categories. So you have 1/2 of it, which is your real numbers. And your real numbers are everything that you've worked with up until this point. This includes integers, right? These are positive and negative whole numbers. You've dealt with rational numbers. Rational numbers are basically fractions. Okay, a fraction can be written, right, like 1 over 3, or it could also then be converted to a decimal. So rational numbers basically consider themselves all of the decimal numbers and all of the whole numbers. And then you have like some of these odd cases like irrational numbers, which are like pi, numbers like that, right? That the numbers have this infinite number of decimals afterwards, but you can't write them as fractions, okay? So they become irrational. So basically, real numbers are any number that you can think of, right? A whole number, a decimal, or a fraction. And then there's this other category here of numbers that are called the complex numbers. And we'll see a little bit more information about complex numbers next week in the next lesson. But for today, what I want you to know is that the complex numbers is where the imaginary numbers fall under. Okay, so the imaginary number lives inside of the world where the complex numbers live. Okay, and the imaginary numbers have this unit. It's called I, right? So there's something attached to this number. It's an I, literally the letter I. That is what identifies itself as being imaginary. Okay, if it doesn't have the I, then it's a real number. Okay, but when it has I, then that's what makes it imaginary. Okay, so just letting you know where that fits in terms of all of the numbers that we work with. Okay, all right, so quick definition here for what I is. Okay, so the number I is the basic element of the set of imaginary numbers. Okay. So basically I is like the foundation. It's like the building block. It's like the number 1, basically, right? Number 1 is like the most foundational number in the real numbers. Well, in this case, I is the most foundational number in the imaginary numbers. Okay, so there's a definition of I, and it goes like this, right? It says that I is equal to the square root of -1. Okay, and by the way, you could do 6 boxes on the front and then 4 boxes on the back. Just so you have enough space for all of your notes. Okay, so if I is equal to the square root of -1, then there is something about I that then cycles through, and this is kind of like additional information, but I just want to show you where some of this comes from, because it's gonna show up. So if I is square root of -1, do we know what I squared is? Right? Could we find it? Well, in order to get from I to I squared, well, what is it that we did? We took I to the power of 2, basically, right? So now imagine that, right, let's go down here, right? Like, right, what if I had I squared, right? Then that means I'd have to square the other side as well. Okay, so by doing so, now it basically lets me know that I squared is equal to, well, here the square and the square root cancel each other out, don't they? So then that leaves us with I squared is equal to -1. So in reality, what is I squared? I squared is -1. Okay. All right. So we know what I is. We know what I squared is. What about I to the third? Right? What if we wanted to know what I to the third is equal to? Okay. Well, let's see if we can break it down. If I to the third, would you agree that I to the third is like saying I to the second power times I to the first? Or maybe the other way around, right? I times I squared, right? You can basically, like, when you're multiplying the same base, you can add up the powers. So 1 plus 2 here gives us the 3. So I've broken it apart. And by doing so, here's what it allows me to do. I know that I by itself is simply just the square root of -1. But then I have this product over here times I squared. Well, we know I squared is -1. So now really what my answer is I have the negative of the square root of -1. Now remember, if a number on the outside, which is -1 in this example, right? This number is outside. The square root of -1, this is inside. Those numbers cannot multiply together. Okay, you cannot suddenly multiply them and then make it the square root of positive 1. It doesn't work that way. So what you have to do is you have to keep that negative 1 on the outside. So it's negative 1 times square root of negative 1. Okay, we don't need to keep the negative 1, you can just keep the negative. So in reality, it's just negative square root of negative 1. Okay, and so we know now that I to the third is equal to negative square root of negative 1. Okay, and now the last one is, what about I to the fourth? Okay, and why is it that I'm going to stop at I to the fourth? Well, I'm going to stop at I to the fourth, and then I'm going to show you that then it's going to start to repeat. It starts to cycle over again. Okay, so when you're dealing with I only has 4 possible answers, depending on whatever power you give it. So if we were to try now I to the fourth, okay, well, would you agree with me that I to the fourth is the same thing as saying I squared times I squared? Right, because in this case, I to the second power, isn't that negative 1? Right, we're getting that from over here, right, that I squared is equal to negative 1. And then I have I squared again, right, so then this becomes negative 1 again. So now I have a product of negative 1 times negative 1, which is positive 1. Okay, so now I to the fourth is actually equal to positive 1. So there are my 4 basic answers, right? I could have I is equal to square root of negative 1. We could have that I squared is equal to negative 1. We could have I to the third, and this one's the least common. This is the one that's almost like least useful. Okay, I to the third, which is the negative of a square root of negative 1. And then you get I to the fourth, which is equal to 1. Okay, and those are the basic, the four main ones that you pretty much need to know. Okay. All right. So why do I bring it up? Because I want to show you that now there is a pattern here that starts to cycle. After I to the fourth, everything kind of goes back to starting with I. Okay, and here's why. What if you tried to do I to the fifth? Wouldn't I to the fifth be the same thing as I to the fourth times I? Right, here this I has a power of 1. So what is I to the fourth? Well, we know I to the fourth is equal to 1, right? We just solved for that. So it's 1 times, well, what's I? I is square root of negative 1. So 1 times the square root of negative 1 isn't going to change it. It's going to stay as the square root of negative 1. So what is I to the fifth? Well, I to the fifth is the same thing as I. Okay, you get the same answer. Okay, because they're both equal to the square root of negative 1. Okay, so you see right after I to the fourth, it basically then goes back here, right? It cycles back. If I were to try I to the sixth, right, that's I to the fourth times I squared. What is I to the fourth? Well, I to the fourth is still 1, and I squared, based on what we know, is equal to negative 1. So negative 1 times 1 is still negative 1. So in reality, I to the sixth is equal to the same thing as I to the second, because those are also equal to negative 1. Right, so that's why I'm bringing it up, because after I to the fourth, you go to I to the fifth, which is the same thing as I. If you go to I to the sixth, it takes you to I squared. If you were to try I to the seventh, it's the same thing as I to the third. And then if you tried I to the eighth, it's the same thing as I to the fourth. Okay, so it all starts to cycle back, because if you divide that number, or if you subtract 4 from it, from the power, it's just a cycle that keeps going back. Okay, so it's not super important, but it was something that I wanted to show you. The most important one to know right now is this one right here. Okay, not even the whole thing really. You just need to know what I squared is equal to. This part right here is really important. Okay, the rest is just a little bit of some enrichment. Okay, so now let's actually try to simplify some of these. let's do some examples. Okay, so let's start here with example number 1. Okay, so with example 1, you're starting with the square root of -3. Okay, our job here is just to simplify, okay, which means write it as something in the most simplest form. Okay, so because we have a negative inside, typically with another problem we would have said this is imaginary and then we stop. But now because we know what I is equal to, okay, now we have to actually convert it. Now here's something that I want to show you guys. There is a rule, okay, there is a rule with square roots, and the rule says this: if I have the square root of and I have a product of two numbers inside, I can split them apart and I can say it's the square root of a times the square root of b. Okay, that rule applies in both directions. So that means that if I have a number and I can find the product of a times b inside, I can split that up as the product of two separate numbers, two separate square roots. Okay, if I have two separate square roots, I can multiply the numbers that are on the insides to go backwards. Okay, so it works in both directions, right? It's like a two-way street. So how does that help us? Well, that's because now I'm allowed to take this square root of -3, and isn't the square root of -3 the same thing as saying square root of 3 times -1? Right? I'm basically trying to write it in a form very much like the square root of a times b, right? I know that -3 has to be the product of a positive number with a negative number. The negative number, I want to keep it as -1, right? There's a reason why, because if the square root of -1 is the magic number I, right? It's the imaginary. So now I can create this split. I can say that this is the same thing as square root of 3 times the square root of -1. Well, the square root of 3, we know that we could turn that into a decimal, but there's no need, okay? However, 3 is also a prime number, so we can't simplify 3 any further, so we're going to keep it as square root of 3. Okay, now I'm going to draw this little tail. Do you see this tail that I draw down here at the end of the square root? I want to keep that, I want to draw it, because now what comes next is I want to convert the square root of -1 into the imaginary number. Okay, so the square root of -1, this goes back to the definition. You can turn the square root of -1 into an I. Okay, so that's what we're going to do as well. So I turn this into an I now. Okay, and that right there is my simplified final expression. Okay, this is what we get as a final solution. Okay, are there any questions on that part so far? Okay, it pretty much it's simple. If I have a square root with a negative number inside, the number stays the same. Okay, so I still keep the square root of 3, but in order to make it positive, I have to take the negative out and then insert an I. All right. So that's it right there for that first example. And that's all we have to do. Okay, we just have to simplify it as much as possible. So if there's a negative inside, we have to rewrite it where the negative is no longer there. You just have to make sure that the I, the imaginary, is now on the outside, right? So you see how the I is outside of the square root? It's not inside, okay? I do not want you guys to write it as 3i inside. That is not correct. Okay, I always on the outside. So I goes outside the square root. Okay, so make a note about where I is supposed to be. Okay, all right, let's take a look at another example now. Let's take a look at example 2. Let me erase this. Okay, so for example 2, we have something similar. It's the square root of -98. Okay, so larger number now, but same idea, same concept. Okay, so the first thing you want to do is first extract the I, right? How do you know that you need to extract an I? Is because there's a negative inside the square root. Okay, so that's how you know that you have to convert it. Okay, so first thing is, well, first we know that this represents the square root of 98 times -1, right? Because there's a product of two numbers inside that square root, we can then split this as the square root of 98 times the square root of -1. Okay, let's do the easy part first, which is take the square root of -1 and convert this into I, okay? And then before we bring down the square root of 98, we need to simplify this a little bit more, because 98, if we left it inside the square root, is not the most simplest way to write that. We need to break it down using a factor tree. Okay, so a factor tree is basically using all of the factors of 98, trying to break it down into the simplest form possible. Okay, so with 98, such a large number, it can be a little bit difficult to find out the factors. So the first thing you should try is, well, because it ends in 8, that means it's an even number. An even number can always be divided by 2. So start by dividing it by 2, so you know that it could be 2 times some number. Well, in this case, that other number, 98 divided by 2, is 49. Okay, so we use 49 as the other factor. Okay, so now 98, I cross it out because it's no longer active. All right, it means that it's not a number that I'm going to consider anymore because I've already factored it. So now you move on to the ones that are on the bottom of your tree. Well, for now, 2 is already in the most simplified form, so I'm not going to factor that down anymore because it's prime. But 49, I can factor that down into 7 times 7. Okay, now 49, we already factored it, so also cancel it out. So look at the remaining numbers you have. You have 7, 7, and 2. Okay, if you want to simplify a square root, if you want to simplify a number like 98, you want to rewrite it as something else, you have to look for a pair of numbers. A pair is, right, the same number showing up at least twice. Okay, well, in this case, the number that shows up twice is 7. Okay, if 7 shows up twice, then 7 gets to escape out of the square root to the outside of the square root. Okay, so what I like to say is you need a buddy to escape jail. So you have to think of the square root. You have to think of the square root as like a jail. Because 7 has a buddy to escape, 7 goes outside. You only write the 7 once though. Okay, so if you have one pair of 7s, then that pair becomes 1 7. Then what happens to the other number, right? The 2. 2 wasn't factored, but we don't have a pair for 2. So where does 2 go? 2 goes back inside of the jail. Okay, so it couldn't escape because it didn't have a buddy, basically. Okay, so now we know that the square root of 98 is also equivalent. It's the same thing as saying 7 times the square root of 2. Okay, so now instead of rewriting the square root of 98, instead of bringing it down, we can instead say this is 7 square root of 2. Drop my tail. Okay, drop the tail on the square root because I is on the outside. Okay, so now my final expression is 7 square root of 2, drop the tail, and then I is on the outside. So now this right here is the simplified version of the original answer. Okay, all right. Any questions there so far? Feel free to stop me and ask a question on the chat if something doesn't quite make sense, okay? Alright, let's try another example similar to this one. We're going to try something a little bit smaller than 98, but something that you still have to break down using a factor tree, okay? Alright, so let's go over here. Let's try example 3. Okay, so let's take a look at a number like square root of -48. Okay, so square root of -48, again, first thing is identify that this is also the same thing as 48 times -1. Okay, then that allows us to split this into 2. So we have square root of 48 times the square root of -1. Okay, the easy part is the square root of -1. Right, because this is the whole point of the lesson, right, is to identify that this becomes the imaginary number I. Now we got to deal with the square root of 48. Well, 48 doesn't have a perfect square root, so we have to use a factor tree to simplify it. Well, 48, man, let's think, could be probably 12 times 4. Okay, so we got 12 times 4. Okay, and then let's say you keep factoring, right? So 48 is no longer active, you keep factoring. So let's say you try 6 and 2. Okay, and up until the moment you don't see any pairs, right? All right, so then keep going. Okay, so now 2 can't get factored any further, so now factor down to 6. You have 3 times 2. Okay, 6 got factored, so now cross that out. Okay, I see one pair, right? I see a pair of 2s, right? So I see this pair. Now notice that they're not attached to the same tree, right? But that's okay, as long as you find factors anywhere on the tree, on any of the branches, as long as you can pair them up, that's okay. All right, so far 3 is a loner, but I haven't factored out the 4 yet, right? So let me factor this down as well. And then that becomes a product of 2 times 2. So take a look, right? We have another pair, right? We have another pair of 2s. Okay, and then so we can establish for sure that 3 is a loner, right? So now, I want to try to break this down, right? So I know that numbers that don't have pairs go back inside the square root. So here, inside of my square root, there's going to be a 3. Okay, what about the pairs of 2? Okay, well for each pair, remember you only write it one time outside. So for this pair, okay, that's a 2. And then for the other pair, that's the other 2. Okay, what do you do with the 2's on the outside? You multiply them. Okay, you multiply those 2 2's. So then in reality, what is that final expression? This is going to be 4 square root of 3. Okay, so remember, for each pair, I only write the number outside one time. Okay, so because there were 2 pairs, then that's why I have 2 different number 2's. Okay, 3 is the only one that's alone, so it goes back inside the square root. Okay, so now I just have to carry this over. Because I know that the square root of 48 is 4 root 3, now my final answer is 4 root 3. Drop the tail, and then there's my I. Okay, so here's my final expression right here. Okay. Any questions so far? Are we doing okay? Okay, like I said, feel free to just drop a question in. Okay. All right. Let's move on to number 4 then. So example 4. Okay, so example 4, we have the square root of -9 times the square root of -25. Okay. Now remember what the first and the most important thing was about this. Take a look at example 2, right? Even example 1. The most important thing here is to always extract the I first. Okay? So when you're dealing with now with a product, right? You have 2 different ones. You have to extract the I before you multiply the 2 numbers inside together. Okay? Remember that there's also a property that says you can do that. Okay, this is the same property here, right? The 2 numbers are separate and you're allowed to multiply them together. But because we're dealing with imaginary numbers, the priority is to extract the I first. Okay, so extract the I. Oops. Okay, then you can multiply. Okay, extract the I. So for the first one, you can see how this one is going to become, well, I know that that's the same thing as the square root of 9 times -1. So then this becomes the square root of 9 times the square root of -1. Okay, now it's easy here, right? Because we have the square root of -1, that's just I. And then luckily we know what the square root of 9 is, right? That's easy too. That's going to be 3. Okay, so literally just 3, straight up. Not square root of 3, just 3. Okay. Alright, now we do the other side. So here we have the square root of, this would be 25 times -1. Okay, so now we have the square root of 25 times the square root of -1. So again, here we identify that this can be rewritten, right? So then we write this as I. And then the square root of 25, that's also pretty easy. That's just I. I mean, that's 5. That's 5. Okay, so now you have a product between these 2 things. Alright, so now you can multiply, right? So you see why it's important to extract the I first, because by extracting the I's, right, now you have this final expression that is pretty simple to clean up, okay? So you end up multiplying here, because it's a product, you can multiply the whole number with the other whole number. So here, 3 times 5, you get 15. Okay, well, what about the i's? Well, you get to multiply the I with the other I, right? Think of it as what if it was like 3x times 5x, right? Same idea, right? You would get 15, and then x times x is x squared. But in this case, it's not x squared, it's I, right? So then instead, you're going to write this as I power of 2. Okay, now why is that special? Why did I spend all this time on the first example showing you what I was, what I squared was, what I to the 5th was? Well, here it is, okay? I to the 2nd power, okay? We know that this converts into something else, right? So if we go back up, right? I told you this is the most important one to remember. I squared is equal to -1. So we have to use that conversion. We have to then convert I squared to -1. So now 15 times I squared, it's no longer I squared, it's actually -1. So here was my final answer, -15. So this is the correct way to do it, okay? Let me show you the incorrect way to do it, okay? What would have happened if you didn't extract I first, right? What if you would have just multiplied the numbers inside of the square roots together and then tried to simplify? Well, here's what happens. You end up with -9 times square root of -25. If you multiply the 9 and the 25 together, let me show you. I have it. -9. Oh wait, let me clear this. -9 times -25. That doesn't show it very well. Forget it. Let's go here. So -9 times -25. That becomes a positive. Oops. That becomes a positive 225. Okay, so it becomes positive. So you get the square root of 225. Okay. Okay. Now, square roots of 225 is equal to 15. Okay, so we get a square root of 225, that's 15. Great, but do you see how the answers are different? Okay, do you see why it's so important to extract the i's first? Because basically what you got here was there's no proof now that for the wrong version, there's no proof that you ever started with imaginary numbers because you ended up with a positive 15, right? So in order to be able to multiply those numbers together, they both have to be positive. Okay, if that was going to be your first step, they would both have to be positive. But because they're both negative, that means that the correct way to do it involves extracting the I first. And then by extracting I, it keeps the I relevant throughout the entire problem. And then at the end, you see why it's relevant, because the I squared becomes a negative. And you end up with -15. Okay, rather than positive 15. Okay, so I just wanted to show you that the possibility of doing it incorrectly could lead you to an entirely different answer, right? It doesn't seem completely different, it's just a negative, but in this case it makes a difference. Okay, so just keep that in mind, to always extract I first. Okay, so that's kind of the basics there, right? There was a product, right? Like an example using a product. Okay, let's keep going. So are you guys on? Yeah, so you might want to go to the back side now if you're out of space on the front. So just a couple more examples. Okay, so let's try here example 4. And now we have a quotient. So we have 4 over 5i. Okay, so just like we don't want negatives inside square roots, we want to extract the I. Similarly, we don't want i's in the denominator either. Okay, so the whole process of example 4 is something called rationalizing. Okay, which is to say remove I from the denominator. Okay, And it's pretty simple. Okay, so notice what's in your denominator. Right now your denominator is a 5i. If you're going to get rid of something from the denominator, then here's what you do. You start with the original problem. And the thing that's causing the problem is the I, the 5i in the denominator. So then you're going to multiply your entire fraction by whatever was in your denominator. So since your denominator was 5i, you're going to multiply top and bottom by 5i. Okay. Guess why it's okay to do that? Well, what is 5i over 5i? It's basically 1, right? So if you multiply by 1, are you really changing anything? Not really, right? So this is why it's okay to do it. So then, now the process is just multiply straight across, right? You're multiplying a fraction with a fraction. So go top with top, bottom with bottom. Well, top with top, here you have 4 times 5i. Remember, you're allowed to still multiply these whole numbers together. Okay, so then what's that going to give you? That's going to give you 20, and then I, okay, 20i. Now the denominator, what's going to happen there? Well, I have 5i times 5i. Remember, you can multiply the whole numbers together. So 5 times 5 will give you 25. And then you can also multiply the I times the I. Okay, remember that this is going to give you I to the power of 2. Okay. So you're probably thinking like, wait, I thought this was supposed to get the I out of the denominator. It will. Okay, so just watch this. I still have 20i in my numerator. There's nothing I can do with that. Okay, remember that you don't want to try to cancel i's, because if you did start canceling i's, you're going to go back to where you came from. Okay, so instead, don't cancel I. Notice what you have now. What do you recognize about I squared? What does it equal? Right? So it's 25. I to the second power, remember that that's just equal to -1. So this is where you transfer. You make the switch. You make the substitution. So now, instead of having an I in the denominator, it switches to a -1. And so really what you have now is 20i all over -25. Okay? So you've accomplished the job of getting the I out of the denominator. Okay? Pretty much. If you were doing this on a test, like, that's 3 out of 4 points. But the only other thing now is I have to simplify it. Right? I want to leave this in the most reduced version as possible. Well, take a look at what 20 and 25 have in common, right? What could you divide out of the top and out of the bottom? You could divide out of 5, right? So if you divide the top by 5, you're left with 4. If you divide the bottom by 5, you're left with 5. So here's what your final answer is going to look like. You still have a 4i in the numerator, you have a 5 in the denominator, and because you had a negative, this is a negative fraction, you could just put the negative right in the middle. Okay? So that's a -4i over 5. I is no longer in the denominator, and you're done. So the fact that -1 comes from I squared is equal to -1 comes from the fact that I is equal to square root of -1. So if I were to square both sides, okay, follow with me here, I squared, well, what happens here with the square root and the square? Well, these are inverses of each other, so they cancel out. So what's left over? It's a -1. Okay, so I squared is equal to -1. That's why I'm allowed to make the substitution from here to there. Okay, so that's just a rule that we can use to help us simplify expressions later on. Okay, I explained it a little bit at the beginning too, but if you weren't here at the beginning, then that might be why you're asking. Okay, so I hope that makes sense. Okay, just remember it's a rule. Okay, I squared is equal to -1, so you're allowed to make the substitution. Anywhere you see I squared, you just substitute -1 instead. Okay, all right, and then just a couple more examples. So let's take a look at example 5 now. So with example 5, we got 10 over square root of -5. Okay, so it's a rationalizing problem, but it's in disguise. Here's why, right? You don't see the I yet. right? There is no I in the problem, but you have a square root of a -5. Okay, so that right there is going to become something that does have an I. Okay, so by now you can probably see, well, let me do a little scratch work. I got square root of -5. So that's the same thing as saying the square root of 5 times -1. If I have the square root of 5 times -1, I can split this up, and then that becomes square root of 5 times the square root of -1. Well, then we know that the square root of -1 goes back to being I. So now really what this is the square root of 5 with the I multiplied to the outside. Okay, so now why does that help me? Because now I can just rewrite this. Instead of the square root of -5, it's the square root of 5 times I. Okay. All right. Now the problem is we're rationalizing, right? We said this is a rationalizing scenario where we try to get the I out of the denominator. So what do you think we're going to multiply to the top and bottom this time? Right? Look at my denominator. My denominator is the square root of 5I. So then I have to multiply the whole thing, top and bottom, by square root of 5 I, square root of 5 I. Okay, so now let's clean up. Let's multiply, right? Numerator times numerator. Okay, well the problem with this numerator is there's nothing that I can multiply together. Why? Because 10 is an outside number, 5 is an inside number. So they don't mix, okay? This is not going to be square root of 50. It's going to be 10 square root of 5 with my I on the outside. Okay, so literally they just get pushed together. It's a product of 10 times square root of 5I times I, but they don't mix. They don't simplify into anything else. Okay, denominator, we got some options. Let's take a look at the square roots, right? 5 is inside of a square root. This 5 is inside of a square root. So then because they're both inside square roots, we can multiply those two together, but keep them inside of a square root. So it becomes the square root of 25. Okay, what else can multiply together? Right, the I, right? It's like multiplying x times x. Well, then in this case, it's going to give us I to the power of 2. Okay, so now let's simplify a little bit. The numerator, nothing to clean up there. Still 10 square root of 5 I. But denominator, check it out, square root of 25. What do you get there? That's a 5. I squared. Well, here, remember the rule, right? I squared, we can convert that into a -1. Okay. So now, my numerator, here's what I have. 10 square root of 5I all over. Well, 5 times -1 is just -5. Okay. So now, whole numbers, numbers that are not inside of the square roots can be cleaned up the same way that we cleaned up the 20 and the 25. Here, my whole numbers are my 10 and my -5, so I can clean both of these up. Okay. So if I divide 10 by 5, that's a 2. And if I divide 5 by 5, I get a 1, right? So I can simplify this. Okay, so what am I going to end up with? Well, I still got 2 square root of 5I in the numerator. In the denominator, it's just a 1, so I don't even need to write it. But it was a -1, so I got to make sure that the negative stays as part of the problem. So you put the negative back up into the numerator. Because 10 divided by -5 would have been -2 anyway. Okay, so then that's my result. That's my final answer there. Okay. How do you guys feel? Do you guys feel okay, or do you guys want to try to do one more? And then if you do, we can do one more example before we wrap up. One more? Alright, sounds good. Let's do it. Okay, so let's just make up some numbers here. let's try, what would this be? Example 6. Okay, so let's try, how about we do 12 over square root of -3. Okay, let's try this. Okay, so first thing is always extract, right? Always extract the I, okay? So in this case, before I start trying to rationalize, make sure that I convert this to 12 is still my numerator, but instead of square root of -3, right, we know that that becomes square root of 3 with the I on the outside. Okay, so now my 3 is positive, but the negative got taken out, so we have the I instead. Okay, now the I is in the denominator, right? We have a denominator with an I, so now we have to rationalize. Okay, if I rationalize, I have to multiply the top and the bottom by the denominator. Okay, my current denominator is the square root of 3i. So then I go ahead, multiply by square root of 3i over square root of 3i. Okay, so now numerator with numerator, denominator with denominator. Let's multiply across. Okay, so now, do you see the 12? You see the 3. 12 is outside, right? 12 is not inside of a square root. 3 is inside of a square root. Those have to stay separate, okay? It cannot become the square root of 36. That would be incorrect, okay? So, you just rewrite it as 12 square root of 3i, okay? All over. And now in the denominator, we got a little bit different type of problem because we have 2 square roots. So the square root of 3, this 3, can be multiplied with the square root of the other 3, okay? But you have to keep them together inside of a square root. So now it becomes the square root of 3 times 3, which is 9. Alright, what about the i's? Well, we multiply the i's together as well. Okay, I times I, that becomes I to the power of 2. Okay. Alright, so far numerator cannot be cleaned up. We still keep it as 12 square root of 3 I outside. Okay, now you can clean up the square root of 9. That's an easy one. That's 3, right? And then we know that I squared, that's the one important one that we have to make the conversion. So then that becomes a -1. Alright, so now 12 over 3. Oh wait, sorry, before we do that, we have 12 square root of 3i, and then in the denominator, 12 times -1 is just a -3. So now we can simplify this, right? Whole numbers with whole numbers. Okay, we can simplify those. So then, 12 divided by -3, well, that's just -4. Okay, because this becomes a 4, this becomes a 1. The negative has to go somewhere, right? You don't want to keep the negative in the denominator if there's no number down there besides 1. So then just bring the negative up into the numerator, okay? Just think of it as, what would 12 divided by -3 be? It would be -4, okay? The rest, you bring it down. So square root of 3i, okay? And there is your simplified expression right there. Okay. Alright, how about now? Do you guys feel a little bit more confident now? Alright, sounds good. Okay, so then we'll stop here. Remember, Thursday I'm going to create a Zoom. So it won't be a live stream like this. I mean, it will be, but you'll actually be able to see my face and I'll be able to see yours, hopefully. because mostly I just want to do homework problems on Thursday. Okay, so we're gonna treat Thursdays as like lab time, kind of like classwork time in a way. So I want you to try the homework, because I want you to have questions ready for Thursday. Okay, and then any questions that you're not quite understanding, then that's when we take care of it. So Thursdays will be short, and then Tuesdays will be our lessons. Okay, so if you have friends, please let them know to watch the videos. Watch the videos, have some problems, have some questions ready for Thursdays. Remind them about joining Thursdays. I know times are hard, so I understand not everybody's going to be able to be live on the live stream, but I only have about 5 people watching, so that kind of bums me out a little bit because we have 28 people in the class. So I get it though. I get it. Things are on your mind, and some of you are helping out family, so I completely respect that. But just let them know, let your friends know, so that they can just try to keep up with the class. Okay. I'll also send out announcements regarding retakes, so that if you didn't do so well on the Unit 5 test, if you didn't do so great on the Unit 5 test, there will be ways to improve the grade. Okay. We'll do like an online version of a retake, just like we normally would in class. Okay. So I'm gonna create a video about how to solve all the questions correctly. And then I will also then upload that. I will send the people interested in doing a retake, I will send you, basically I'll send you whichever problems you didn't get 4s on. I know it was a little bit tricky because you sent me problems on paper, and then I graded them based off of that. So I didn't actually write any comments. But I'll send you the problems on how to do them correctly. You just basically take the notes down, you study those, and when you're ready for your retake, you let me know, you take the retake, just like always. Okay, so that'll be the only difference. But other than that, have a good day. I'll see you guys on Thursday. So look out for the Zoom link. I'll post it on Schoology, and then we'll meet then. Okay, so don't forget, homework is on Schoology, so it'll be right here. Okay, so 1 through 20, and then again, like I said, the solutions are down towards the bottom, so you can check your work to see if you are understanding it. Okay. All right, that's it for me. I'll see you guys later. Have a good one.